What's going on, Science 10? I hope you had a good spring break. It's Mr. Walton here, back at you with some more physics. So we're learning about the metric system right now, and the metric system is all about powers of 10. I don't know if you know what the metric system is. We kind of use it in Canada. We're supposed to use it in Canada, but we don't use it for everything. Now, the metric system was created in the late 1700s by some French scientists, right around the time of the French Revolution. The metric system is a system of units that are related to each other by powers of 10. So an example of that is in 1 kilogram, there are 10 hectograms, 100 decagrams, and 1,000 grams. And so you'll notice that all of these are basically powers of 10 of each other. So inside 1 kilogram is 10 hectograms, 100 decagrams, and 1,000 grams. A big part of the metric system is the use of prefixes. So when we say kilogram, they're all grams, but they're just different versions of the gram. And so a kilogram or kg is different from a hectogram or hg, decagram, dag, or gram is just g. It has no prefix. So this is a very common, and you'll get used to seeing this as time goes on in our science courses here at Lindsay Thurber. But let's just kind of move on. We can convert metric units by using the following table simply by shifting the decimal place of the number. So remember, 1 kilogram, this is going to be really important. You're probably going to want to commit this to memory. It's just going to be easier that way. 1 kilogram is equal to 1,000 grams. So if I want to convert from a kilogram to gram, I have to multiply. If I want to go from gram to kilogram, so if I want to go from kilogram to gram, I got to multiply. If I want to go from gram to kilogram, I got to divide. And the reason why that is because inside 1 kilogram, there are 1,000 grams. So 1 kilogram is like a giant unit of mass. 1 gram is a little teeny tiny amount of mass. And so it takes many, many, many small things to add up to be a big thing, right? You can think of, just many, 1,000 of these tiny little grams. That's what makes up a kilogram. And so just think about it this way. If we're converting from a big unit, a kilogram, into a small unit, we're going to need many of those small units. So we're going to get bigger. The number is going to get bigger. It represents the same amount, but the number in front is going to get bigger. Okay, let's move on. We can convert metric units by using the following table, simply by shifting the decimal place of the number. So in here's our table for the metric system, and this can be found in your data booklet. So it's got the prefix in front of whatever the common base unit. Common base units are typically meters, grams, liters, moles, but they could be other metric units. There's candelas, or for how bright something is. But mostly we're going to use meters, grams, liters, and moles. So we could have kilometers or a kilometer. We could have kilograms. We could have kiloliters or kilomoles. Okay, so we would represent them as km for kilometer, kg for kilogram, kl for kiloliter, and kmol for kilomole. Now, don't worry so much about mole. That's a big part of Chem 20, but it's not a massive part of the Science 10 curriculum. So let's take a look at other parts of this. So the name of the prefix is way on the left-hand side here, and then the symbol we use for the prefix is in the second column. And this kind of complicated section at the end here, that just means how many base units make up one of those other units. So in a giga something, in a gigaliter, there are 1 billion liters. That's what a gigaliter is. We could also say a joule, right? In a gigajoule, there are 1 billion joules, okay? So what we're gonna do is we're gonna use this table to be able to convert from one unit into the other. And all we're gonna do is we're gonna shift the decimal place over. And when you look on the side here, you're gonna find, like, for example, convert kilograms into grams. Well, kilo something is here in green, and then gram something, I'll do that in blue, that's a base unit, so that's here in blue. So if we want to go from green to blue, we're going from a big unit, okay, we're going from a big unit, kilo is massive, right, to a smaller unit. When we go from a big unit to a smaller unit, we need many smaller units to make up the big unit, okay? So what we're gonna do, and I just gotta shift this a little bit. This is gonna be complicated. I just gotta shift this a little bit. Oh. There we go. So I want you to notice the difference in the exponent that's written on the side here. So the difference between 3 and 0, 3 minus 0 is 3. So we're gonna move our decimal place 3 times. And remember, because we're turning into a smaller unit, we need a bigger number. So we're gonna move our decimal place to the right, okay? So 0.15 kilograms. If we want to turn this into grams, we have to move our decimal place over. 3 minus 0 is 3 times. So 1, 2, 3. So it'll be right there. And we're going to fill in the rest with zeros. So let's rewrite this as a number with a proper decimal place in zeros. So this would become 0.150 decimal 0 grams. And typically we would take into account significant digits, but I don't want to worry about that right now. We don't want to worry about significant digits right now. We'll worry about pooling everything together a little bit later on. So all we had to do was we had to move our decimal place 3 times to the right. And hopefully you'll kind of recognize, I'm going to delete those and I'm just going to put 0 or gram there. So 0.15, a small number, became 150, a big number, because we're moving to a smaller unit. The size of grams, 1 gram is way smaller than 1 kilogram. And so whenever we move from a large unit to a small unit, we got to move our decimal place over so that we get a bigger number. Okay, now we're going to convert 846 millimeters into meters. So again, I'm going to take a look over on the side here. Millimeters, I'm going to highlight in purple. And then meters, I'm going to highlight in red. Meters is our common base unit here because it doesn't have a prefix in front. So let's take the difference between these. How many exponents are in between 0 and -3? 0 minus -3 is 3. There's 3, steps in between here. So I have to move the decimal place 3 times. But hopefully you notice I'm going from a small, milli is very small, and meter is our base unit. That's, relatively big. So we're going from a small unit to a big unit. Our number needs to get smaller. So it's almost like we're dividing by 1,000. So we're going to go 846, and this is where the decimal is. So we're going to move our decimal 3 times because that's the difference between this exponent and that exponent. So let's move it 3 times. 1, 2, 3 in the direction that makes the number smaller. So we'll get 0.846 meters. And so hopefully we can all agree that 846 is a big number compared to 0.846. But if we have many small things, that could equal a small amount of big things. Hopefully that makes sense. So 846 millimeters is the same thing as 0.846 meters. So that's how we're going to use this chart. We're going to use this chart. We'll just take the difference in the exponents, and that's how many times we have to move the decimal place. So please remember or notice that many smaller units fit inside a big unit. So the number will go up when you convert from a large unit to a small unit. That's what we did in the first example. Went from a large unit to a small unit, so the number went up. And it will go down when you convert from a small unit into a big unit. So let's do a few more examples. And what I want you to do is I want you to pause the video right now so that you can try these on your own. And so I'll give you a couple seconds. You go ahead and pause the video, try them out. And if you have any problems, unpause the video, play the video again, and we'll work through it together. Okay, let's go ahead and try this. So convert the following units. So 0.0934 kilometers into meters. Well, that kilometer, let's go back up to the top. Kilometer is a big unit. When I look at this, kilo is bigger than the base unit. So I'm going from a big unit into a small unit. And when I go from big to small, I got to move the decimal place so that I get a bigger number, right? A small amount of big things is equal to many small things. Okay, so let's try 0.0934. And I got to move the decimal. The difference between kilometer and our base unit is 3 steps. So I got to move the decimal 3 times to make it bigger. 1, 2, 3. 93.4 meters. Perfect. That's exactly how many meters there are in 0.0934 kilometers. So all I did was I moved the decimal place 3 times, and I moved it so that we got many small things. So a small number of big things is equal to a larger number of small things. Perfect. Let's try the next one. Let's go 15,400 millimeters into meters. So I'm going to go from millimeters into meters. And so that's a difference of 3 steps. Okay, so this is a small unit and we're turning into a bigger unit. So the number's got to get smaller. So 15,400, and this is where the decimal, right? The decimal is right at the end. So we're going to move this 3 times to make it smaller. 1, 2, 3. So 15.4, oh, not kilometers, but just meters. Perfect. So 15,400 millimeters is the same thing as 15.4 meters. And this, hopefully you can understand that just moving the decimal makes this a really fantastic system to use. The metric system is an awesome system for us to be able to use. 2 more examples. So 53 kilometers into meters. So we're going from a big unit into a smaller unit. And kilometers is up here, and we're going into our base unit. So that's 1, 2, 3. I'm going to move the decimal place 3 times. So 53, that's right there. I'm going to move it in. I'm making a small thing, so the number's got to get bigger. So 1, 2, 3. That's my new decimal place. And I fill in zeros. So 53,000 meters. 53 kilometers is 53,000 meters. No problem. And then last is the exact opposite. 6,750 meters into kilometers. This is a small unit. A meter is smaller than a big kilometer. So we're going to have to go, and it's the opposite. It's the same number of decimal places. So we're going to move the decimal place 3 times. 6750, 1, 2, 3. So 6.75, and I'll say 0, sure, kilometers. Hopefully that made sense. I've linked in the instructions for today, I've linked another video that Mathantics did. They're a fantastic channel. So if you didn't totally get what I did here, then go ahead and watch the Mathantics video. What I'd like you to do in the next one, oh, this is sideways, sorry. Okay, sorry about that. What I would like you to do on the next page is I would like you to try some of these metric conversions, and it's going to spell out a little bit of a joke. So the joke is, why did the hen jump up and down when she looked into the nest? And then down here at the bottom is going to be the punchline to the joke. They're usually pretty corny, but it's okay. Just try and it'll be okay. Calm down. So complete each statement, then find the answer in the set of answers to the right. Write the letter of the exercise in the box containing the number of the answer. So it's saying for G, convert 3.8 meters into dm. Now dm is decimeter. So if we go from meters to decimeters, so that's going from a big unit to a small unit, and it's going 1 down. So what we're going to do is we're going to shift this 1 over. So this is going to be 38, and the decimal will be there, so 38 decimeters. So G will be the answer to 17. So I go down here, 17, and G will be the answer there. We'll do a couple more examples. 38 meters into centimeters. So centi is even smaller. So we're going to go even further. So 1, 2. So 380 centimeters. So 2, the number 2 is going to have the answer T because they're both 380. So T. And then finally, 3.8 meters into millimeters. So we're going to move 3 times. So it's going to be 3,800. 3,800 is 24. So 24 is M. So you're going to do this, and you're going to spell out the punchline for the joke. Just try it out. I will have the punchline. I will have everything solved for you in the notes of this lesson. Let me know if you have any questions. Email me or use the questions document. So far, nobody has used the questions document. Or come see me in the office hours from 10:45 to 11:15 every single day that we have class. Let me know if you have any questions. Otherwise, I don't know. I'll see you around.